This is Mr. Bloom, and this is day 2 of chapter 7. Are you ready? Now, we are currently going through and we're checking out this idea of FOIL. So we're going to take the first and we're going to multiply the first, the outsides, the insides, and the last. So that's what we're going to do. So the first, x times x, x squared. Okay, the outsides, 3x, and that's a positive 3x. The insides, 5x. And now the lasts. The lasts are 15. And that's where we get the words FOIL. Okay, now part of this FOIL is being able to combine our like terms. So the first, x squared, and then the outside and inside term combine and add together to be 8x, plus the last, which is 15. I want you to notice that our outside and inside terms are factors of 15, and our outside and inside terms are summed together to be our middle term, 8. So when we're going to unfoil, if I'm going to unfoil this, I'm going to do it in the reverse. I know we already seen the answer, but what we're doing is we look at that leading term here. There's a 1, there's a 1 there, so I go x and x, and now I've got to find two numbers that multiply to be 15 but add to be 8. The factors of 15 are 1 and 15, 3 and 5. Okay, now I've got to look at these factors and decide which one of those will add to be 8, and it'll be 3 and 5. Now I got to keep in mind that because this is plus, the sign in front of the 3 and 5 is even both negative or they're both positive. This tells me they're both positive and it's 3 plus 5, so that's what I have for my factor. So I've broken this down in the factors. My x squared plus 8x plus 15 has been factored to become the quantity x plus 3 times the quantity x plus 5. Now, we are doing this unfoil, okay? So when a is 1, this is fairly easy because we don't need to worry about the first terms. We are really just in search of two factors of the last term, c, that add up to the middle term, b. So this is our middle term, 11. This is our last term, 30. And please notice all our last terms here are 30. So what we're going to do is talk about the factors of 30. I got 1 in 30 multiplied to be 30. I got 2 in 15 multiplied to be 30. 3 in 10 multiplied to be 30, and 5 in 6. All these are possible factors that will multiply to be 30. That'll make our final thing. Our middle term is made by a combination of either adding or subtracting the two factors that make 30. So let's start. When I have 1, it's great because it's just x and x. Now I have to think about which one of these 4 sets of factors are going to help me make 30 and add to be 11. 1 and 30 is going to be 30, or it could be 31 or 29 if I add them or subtract them. 2 and 15, if I add them, it's 17. Subtract them, it's 13. 3 and 10, if I add them, it's 13. If I subtract them, they're 7. And 5 and 6, if I add them to be 11, subtract to be 1. But wait, 11. Ooh, this is the one I'm going to use right there. So I'm going back here. I'm going, hey, I'm going to use 5 and 6. And they both are plus signs. Now, I can check my work by just doing FOIL. My first, remember, x squared. My outsides, 6x. My insides, 5x. My last, 30. And I add them all together, and it's x squared plus 11x plus 30. Now, I checked my work here, and it doesn't ask me to, but I should be able to factor a trinomial to two binomials multiplied, and take those two binomials and multiply them together and bring them back to the original problem, and it should be the same. Okay, if I'm wondering, gosh, did I do it right? But again, I'm just working with these factors of 30. Okay, so over here, we're looking at x and x, and now we're changing the signs up. This is plus and this is a negative. When this is plus, that means both signs have to be positive, both signs have to be negative. When this is negative, they're both going to be negative. I know that already. So I've got to find two values that will multiply to be 30 and add to be 13. Yep, 10 and 3 are it. So we got 10 and 3. And it doesn't matter where I write them. I could have written them over like this because the leading terms are on my x's or 1s. It doesn't matter which position I put the 3 and 10. Okay, so that's factored, and we can again check it by FOIL. X squared minus 3x minus 10x is minus 13x plus 30. So I've checked my work. Didn't you notice I went faster on that because FOIL is a mnemonic device to help me quickly multiply two binomials. Now, keep in mind, I'm still going to use these factors. Okay, now I got this plus 13 this time and a minus 30. Wow, plus 13 and minus 30. It's not going to be the same that we did before. Still, I have the x's. And I've got to make sure when I look at this, I got that minus 30 there. And to make it a plus 13, a bigger value is positive and the smaller value is negative. Why do I know one is positive, one and it's negative? Is because of this sign. Okay, so I'm looking at 2 and 15, and I've got 15, that's positive, and the 2 is negative. So now when I've got that going, I've got that factored, and again, I can check it. X times x is x squared. 15x minus 2x is plus 13x. And then I'm looking at 15 times negative 2, and I get negative 30. And that's what I started with, so I've checked my work. So going on, sorry, had to get some water there. We're looking at x and x, and I've got 30. In order for them to be 30, I've got to go, again, use the same factors. Here, one of these factors, I feel like, hey, it's random. We just pick them out. But which one of this set of factors has a difference of 1? Ooh, this one right here, 5 and 6. Well, I know the 6 has to be a negative. So the 6 is negative, the 5 is positive, and that should come out as I check. So if my first is x squared, my outside is 5, my inside's negative 6, when I add them, I get negative x or negative 1x, and I multiply them, I get negative 30. So I've checked my work. So I've got that going on, and I'm going to go to our next page. Now, I want you to try this. Give it a try, shut me off, and give me a try and see how it's going. Okay, we're back. And keep in mind, 9 is 1 times 9 and 3 times 3. The only combination that makes an addition to 10 is 1 and 9. So I've got x, and I've got 9 and 1, or 1 and 9. I could put them in either order. Okay, and again, I'm just going to check my work. X squared plus x plus 9x plus 9. Well, gosh, that's going to be x squared plus 10x plus 9. I've checked my work. Now, do the other one. If you haven't, shut me off and go ahead and do it. Now, in this other one, when you come back here, I've got 48, and that's 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8 are all factors of 48. But now I've got to look for a factor of 48 that has an add or subtract to be negative 8. Okay, now an add or subtract to be negative 8 is going to be tough. Now, if it's going to subtract to be a negative 8, that's cool, but that means that this is I've made a mistake here, and we have to make a correction on our thing. So it's correct this problem, okay? Correct this problem. We need to make this a negative right there, okay? So now that we've got that corrected, That's going to be a negative. Let's go after this solution. So now, and that should have been done, by the way, by us. We have a typo in the problem. I'm going to use 12 and I'm going to use 4. They're different than 8, but I'm going to say 12 is negative because this is a negative. The bigger one has to be negative. The smaller one has to be positive, and because they're different, there has to be a negative sign there. Okay, it has to be a negative sign. So the first was x squared. The outside was negative 12x. The inside was positive 4x. The last was negative 48. And now we got x squared minus 8x minus 48 is correct as our answer, and that's why we had to make that change to be a negative sign. Now, we don't always have that leading term, the a part be a 1. And remember, the a we're talking about is ax squared plus bx plus c, and that's where the a would be something other than 1. But one of the nice things when it's a prime number is I only have one thing to do with it. Okay, when I take 2, it's just 2 times 1. I got options for 6, 1 times 6 and 2 times 3. And I could put it in 6 and 1 and 3 and 2 in the different positions. So maybe I should write it down here. And these are my possible combinations down here for this other part. So I got to start thinking, how would I want to do that? I got to get to 13. All these make 6, but I got to make 13. 6 times x and 1 times 2 is 8. But if I flip-flop 1 and 6, that would work. So I could go 1 here and a 6 here. And they're both positive. So 6 times 2 is 12. 1 times x is 1x. So that allows me to get my 13. Okay, and just as a check, 2x squared, that's my first. My outside is 12x. My inside is x, and they are added together. And then I add 6. So I've got 2x squared plus 13x plus 6. And we got it made. Now, this next one's going to be a little tougher because I could have 6 and 1 as a check or 2 and 3 for my leading term, because the things that make 6 are 6 and 1 and 2 and 3. The things that make 5 are 5 and 1. That's it. So it makes it nice. I'm trying to make 13 here, and I'm trying to make it with plus signs. And if I'm looking at this, I'm thinking, wow, I'm going to get this to be 13. What if I go 5? Because I could go, what if I go 5 times 2 and 3 times 1? That's 13. Okay, and people are, wow, what? So I'm going to write stuff down, 2x and 3x. I decided to split them. Okay, now, why? Because I'm going to put a 5 someplace and a 1 someplace. Okay, and maybe I should write those with different colors so you know that I don't know for sure. So if I pop those in here and here, this is going to be, this will make a 15, this will make 2. Well, that's 17 or 13, but I have to have the same signs. So that won't help me that way, but I could do this. And that's going to be 3 and 10, and if they're the same signs, it'll totally work. Okay, that makes me happy. All right, so now I've got 6x squared, my outsides plus 10x, my inside plus 3x plus 5. And that's going to totally help me get 6x squared plus 13x plus 5. So I got that done. That's what the problem was. I'm very pleased with it. I'm going to move on, and I'm going to have you give this one a try, because these last 3 are kind of tough, but I want you to give this one, example 2, a try, and I'll do example 3. Go. Oh, hey, turn me off. All right. You're probably ahead of me. I got 3x and x. Now, what's cool about 4, I got 2 and 2 or 1 and 4. That's it. 2 and 2, 1 and 4 is it. And those aren't very clear, so we're going to write those down again. I got 1 and 4 and 2 and 2. Well, if I go 4, and keep in mind I got negative. So that means both of them have to be, this means both have to be the same. And they're both negative. This tells me that that same is negative. So both of them are negative, or I'm subtracting. And in order to get to 7, I could put a 2 here and a 2 here, but if I do that, if I do a 2 and a 2, I get 8, and that's not 7. Okay, and it doesn't matter which order I do. But if I do a 4 and a 1, this way, it will let me get the 7. I got a 4 there and a 1 there. That'll be 4x and then 3x and add them together to get my 7. All right, so now I've got 3x squared, and this is my check. That's my first. My outside is negative 3x. My inside is negative 4x. My last is positive 4. And I have 3x squared plus, minus 7x. Plus 4, and that's what we were supposed to find. So that's good to go. This is our answer. Okay, if we were supposed to factor. Now, this one with the negative here, okay, different signs. One is added, one subtracted. This tells me, since it's positive, big value is positive. Okay, so now I know 5 is prime, so it's nice that I just have that choice there. But 9 is 1 and 9. So 9 is 1 times 9, okay, and 3 times 3. So those are the things I'm going to try. 1 times 9 and 3 times 3. I always have those things connect. That's interesting. Okay, so those are the factors I'm going to do. So let's check these out. Now, 1 and 9 and 3 and 3. Now, if I put in 3 and 3, it makes it tougher because that means I got 15 and 3, which is 18 or 12, or 12 because the signs would have to be different. If I put in 1 and 9, if I put a 9 here and a 1 here, I would get 45. It's way too big. But if I put the 9 there and the 1 there, and pay attention to that, the bigger one has to be positive, I can get away with it. Okay, so now let's check. I got 5x squared. That's my first. My outside's negative 5x. My inside's positive 9x. My last is negative 9. And I got 5x squared minus 4x minus 9. Or excuse me, plus 4x minus 9, because this is a plus and that's a plus and that's a negative. So I've checked my work. This is my solution. My last one here. Okay, I got a prime and a prime. I love primes. Okay, I just got 2x. And the primes I'm talking about are the 2 and the 5, because the only factors that make them are 2 and 1 and 5 and 1. That's an x, and now I got to figure out where to put the 5. Well, if it's going to be negative here and positive here, they're both negative. Okay, so now I just put a 5 here and a 1 here, and I can come up with my 7x. Because this is 5x, this is going to help me get the 7. They're both negative, so I'm just going to double check. 2x squared minus 7x plus 5, it checks, and this is my solution. Now, today's assignment is on Delta Math, okay? Oh, we're supposed to discuss the solutions to a quadratic equation and what they would be if each trinomial above were set to 0. Solutions to quadratics, okay, and you guys have seen the quadratic equation. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a gives me the zeros where the graph of the quadratic crosses the x-axis. So if each one of these was set equal to 0, our solutions would help us know what that would be where it crosses the x-axis. We'll do more of that tomorrow when we talk about the quadratic equation. But for today, we're looking at our factoring, okay, in Delta Math, and you'll be able to find that on the board or on the instructor's agenda card, the daily agenda card, and we'll be able to get that done. We'll be in Delta Math this week for your assignments. Now, if you have questions that I can't answer because, you know, I'm on tape, please ask your local geometry teacher the question that you have. Don't keep it to yourself. And as always, I'm Bloom, and you're not. I hope you have a great day.